Hello, and welcome to another lesson from Level Up Mathematics. Today's lesson, we will be solving two-step inequalities. This is part 2 of a two-part lesson. Let's start off with a little review about how numbers are ordered on a number line and compared with inequality symbols. So in example 1, it says -6, -4, -2, 2, and 4 are plotted on the number line below. Place a greater than or less than symbol in each circle to make the statement true. So in problem A, we're comparing 4 to 2. So if you notice, 4 is to the right of 2. So we know 4 is greater than 2. All right. Problem B, we're comparing -6 and -2. So in this problem, notice that -6 is to the left of -2. So we must use a less than symbol. So -6 is less than -2. Pause the video and try problems C and D on your own. When you're ready to check your answers, press play. All right, welcome back. On problem C, we were comparing -2 to -4. So -2 is to the right of -4. Therefore, -2 is greater than -4. For problem D, 2 was greater than -6 because 2 is to the right of -6. All right, example 2. Given the true inequality, 12 is greater than 4, do the following to both sides and state whether the new inequality is true or false. So in problem A, they want you to add 3 to the 12 and the 4 and then determine whether the inequality is still true or did it become false. So if I add 3 to 12, I get 15. If I add 3 to 4, I get 7. So ask yourself, is the new inequality still true? Well, 15 is greater than 7, so the new inequality is true. All right, let's see what happens if we subtract 2. 12 minus 2 would be 10. 4 minus 2 is 2. Is 10 still greater than 2? Yes, our new inequality is true when we subtract 2. What about when we multiply by 2? Will the inequality still be true? Well, 12 times 2 is 24. 4 times 2 is 8. And 24 is greater than 8. So when we multiply by 2, our original and our new inequality are still true. What happens when we divide by 2? 12 divided by 2 is 6. 4 divided by 2 is 2. 6 is still greater than 2. So this inequality is true. All right, problem E. Let's talk about what happens when we multiply by -3. So 12 times -3 is -36. And 4 times -3 is -12. Is that inequality true? Well, this inequality is false because if you think about your number line, -36 would be down here somewhere and -12 would be up here somewhere. Excuse me. So this new inequality, when we multiplied by -3, our inequality became false. All right. What about if we divide by -2? 12 divided by -2 gives me -6. 4 divided by -2 is -2. Is -6 greater than -2? No, that's false because -6 would be here and -2 would be here. So -6 is actually less than -2. Excuse me again. All right, how about if we multiply by -10? That would give us -120 is greater than -40. Well, again, that's false. Let's try dividing by -4. 12 divided by -4 would be -3, and 4 divided by -4 would be -1. That is also false. So what do you notice when you multiply or divide by a negative, okay, what seems to be happening to your true inequality when you multiply or divide both sides by a negative? So the true inequality becomes false when multiplying or dividing by a negative number. So that leads us to a very interesting property of inequalities when we're trying to solve an inequality. When solving inequalities, we solve them just like equations with one exception. When multiplying or dividing by a negative, we must reverse the inequality symbol. And only when we're multiplying or dividing by a negative. So we'll practice with that some. All right, let's look at example 3. Solve each of the following and graph the solution set. So in problem A, we have negative 8x plus 40 is less than or equal to negative 16. So I'm going to start by subtracting 40 from both sides. So I'll bring down the negative 8x. The 40s will zero out, is less than or equal to. Now here we have negative 16 minus 40. Remember, when the signs are the same, we add them up. So that would be negative 56. Now to finish this, we're going to have to divide both sides by negative 8. But remember that interesting property that says if we multiply or divide by a negative, we must reverse the symbol. So this would become x is greater than or equal to. Here, a negative divided by a negative would be positive 7. So to graph our solution, I want to put 7 in the middle and then 6, 7, 8. I'll put a filled in circle at 7, and I want to shade the number line, the portion of the number line that is greater than or equal to 7. So that would be this direction to the right. All right, problem B. 4 minus 5g is greater than 39. Now, when I'm solving equations and inequalities, I like the variable to come first. So I'm going to rewrite this problem. You do not have to do this step, but I like the variable to come first. So I'm just going to rewrite this as negative 5g plus 4 is greater than 39. Now to solve it, we'll subtract 4 from both sides. And that will give me negative 5g. The 4's will zero out, is greater than 39 minus 4 is 35. And now I'll divide both sides by negative 5. And remember that special property? Because we divided by a negative, we must take the greater than and reverse it to less than. 35 divided by negative 5 would give me negative 7. So this time negative 7 is in the middle, and we would have negative 8, negative 6. We want an open circle at negative 7, and less than, we shade to the left. All the values that are less than negative 7. All right, problem C. 2c plus 7.5 is greater than negative 1.5. So I'll start by subtracting 7.5 from both sides. So 2c, this would zero out, is greater than. Here the signs are the same, so we'll add them. 1 plus 7 is 8. 0.5 plus 0.5 is 1, so this would be negative 9. Divide by 2, divide by 2. Now, notice on this problem, I'm dividing by a positive. So do not reverse in this problem. So c would be greater than negative 9 over 2. Now, to plot this, I'm going to have you write that as a decimal. Negative 9 over 2 is equivalent to negative 4.5, simply because it's easier to graph a decimal than it is a fraction. So I'm going to put negative 4 here, negative 5 here, and negative 3 here. To graph greater than negative 4.5, I would put an open circle at negative 4.5, and I would shade to the right since it's greater than. All right. Problem D. 5 is less than or equal to negative 1/2 x plus 3. Now, I like the variable to come first. So I'm going to put the negative 1/2 x plus 3 on the left side, and I'm going to put the 5 on the right side. The only thing you have to be careful here is notice that the inequality symbol is opening up towards your algebraic expression. So make sure it still opens up towards your algebraic expression when you rewrite it, okay? Now, from here, we'll subtract 3. So negative 1/2 x, the 3's zero out, is greater than or equal to 5 minus 3 is 2. Now, to get rid of a fraction, we multiply by the reciprocal. And the reciprocal of negative 1 over 2 is negative 2 over 1. And remember, when we multiply or divide, when we multiply or divide by a negative, we must reverse the symbol. So x would now be less than or equal to negative 4. So negative 4 will go in the middle, put a negative 5. Negative 3, I want a filled in circle. And for less than, we shade to the left. All right, problem E. Negative 5 plus 3x is less than or equal to 10. Pause the video, try this problem on your own. When you're ready to check the answer, press play and come back to check. All right, welcome back. I rewrote this problem so that the variable came first, and then I solved it. So I have 3x minus 5 is less than or equal to 10. I added 5 to give me 3x is less than or equal to 15. And then I divided both sides by positive 3, so I did not reverse the symbol. When I graphed it, I put a 5 in the middle, 4, 5, 6, and I put a filled in circle at 5, and for less than, I shaded to the left. For problem F, I rewrote this where the variable was on the left, so negative m plus 2. The negative 3 was on the right. Now, I noticed that my symbol was opening up towards the negative 3, so I had to make sure it was still opening up towards the negative 3 when I rewrote it. Then I subtracted 2. So negative m is less than negative 5. Now, remember, this is an understood 1, so I'm going to divide both sides by negative 1. And when we divide by a negative, we reverse the symbol. So negative 5 divided by negative 1 is positive 5. So 4, 5, 6. Open circle at 5. For greater than, shade right. And that concludes today's lesson, Solving Two-Step Inequalities, Day 2.